everyone, so welcome to my channel. Today we are going to do Leetcode daily challenge, sort the matrix diagonally. So basically in this question, we are given with the matrix diagonal. We are not given with the matrix diagonal. We are just given with the matrix. I am just reading the statement here. A matrix diagonal is a diagonal line of cells starting from some cell in either the topmost row or leftmost row and going in bottom right direction until reaching the matrix end. So for example, the matrix diagonal starting from matrix of 2, 0, that is, although they have not given here, because if you see about the 2, 0, that is second row and 0th column, right? In this particular example, so it will be this one, but they have taken example for 6 cross 3 matrix. So yeah, I can draw that example for explanation here. So it is 6 cross 3 matrix, right? So let us have, these are 3 columns and these are the 6 rows, 2, 3, 4, 5 and 6. So they are saying about that it is 2, 0, right? So that means 0, 1, 2, 3, 4, 5, 0, 1, 2. Okay. So it is from 2 until 0. So they are saying the diagonal which is starting from this includes cell of the matrix, that is this first, and then 3, 1, that is 3 and this one, so this one, and then it says 4, 2, that is this one. So it is saying that this is the diagonal which it will include, and then given an m cross n matrix of integers, sort each matrix diagonal in ascending order and return the resulting matrix. So basically here we are required to sort this matrix, but the only condition is that we are required to sort this matrix in a diagonal manner. So all the elements which are there on a particular diagonal, we are required to sort them in that diagonal manner. So that's the thing which we are required to do here. So this is what is required by this question. So now comes the part that how we would be proceeding for going to this particular question. So let us have one example. I don't think so we require example because it is pretty much clear. But yeah, for building up the intuition we require. But before that, let us go through the constraints which are being given to us. As it is a matrix, so m and n constraint will be surely such a smaller constraint so that we could easily able to come up with m cross n solution, that is n square solution. So that's why the constraints of m and n is 100 only, so that if we are, because in a matrix surely we are required to go for each row and each column, so that's why the solution would be surely like this, that is 10 raised to the power 2 into 10 raised to the power 2, that is the whole solution would be this, means this much of time complexity, so that there is no TLE, so that's why the constraints are in this manner. And then comes the part that each element in the particular matrix is basically 100. So yeah, presently we are not much concerned that what each element is about, because we are not adding up or something, we are just as it is taking. So that's why these are the constraints which are pretty much clear that what sort of time complexity for this question could be. So it would be about n square, basically m into n, right? So square time complexity solution it would be. So now let me show you that how we are required to do this question. So for that, first thing which is there, we require the count of diagonals, that how many diagonals there would be. So the first thing is that how we are required to check that how the number of diagonals are there. So basically this one, this one, this one, this one, right? So each diagonal starts from this. Oh, okay, my cursor is not visible. Basically the first row means number of columns which are there, that is one of the count for diagonals. Then the second, then the number of columns which are being there, that is also the count. Basically the first row, it will correspond to the number of columns, and the first column will correspond to number of rows. So adding up all of them and then deleting just one row or column means basically subtracting -1, because there is this one which is basically added up in both, right? So we are required to subtract -1. So these number of diagonals we are having, because you can clearly see one diagonal starting from here, one is here, one is here, one is here, right? So these are the number of columns, and then one is starting from here, one is starting from here. So these are number of rows. So that's why diagonal is basically equals to row plus column and -1, which is for this particular common, right? So this is how we will be able to get the count of the diagonals, right? Now comes the part that how we would be sorting each diagonal, right? So we will be starting from the first, okay. So what we would be doing, we will be starting from the, it is not available, okay. We will be starting from the first diagonal itself, right? And after starting from the first diagonal, we will be going till the bottom end of that particular diagonal, and we will be storing all the elements which are being there in this particular diagonal. So that is the thing which we would be doing here. So here we are having 1, 2 and 3, right? And this is from this diagonal only, right? So here it was already not sorted, right? So here after sorting we got 1, 2 and 3. So what we would be doing, we will be storing all these elements in a particular temporary vector which will be having a dynamic sizing, and that dynamic sizing would be as per the size of the diagonal which is being there. And how we will be getting the size of the diagonal, that will be corresponding to the row and column which is at that particular moment. So here we can start from either from row 1 or column 1, right? So according to that we will be going till the end, and then according to that we will be pushing our elements into our this particular temporary diagonal, and then after sorting that diagonal we will be again assigning these elements to our original matrix. So that's the thing which we will be doing here. Basically the key concept which we are required to keep in mind is that how we are required to get the diagonal and how we are required to fetch all the elements which are required to be pushed into a temporary diagonal, and how we are required to assign back to our original matrix for returning the result as sorted matrix according to the diagonal elements. So this is the thing which we are required to do. Now let me show you the explanation for this code, and then we will go for our code walkthrough. So here I have already explained that how we are required to count for the diagonals, right? So for covering all the diagonals, what we would be doing is, okay, now everything is visible, right? So first thing which we will be doing is, we will increment the column index until it reaches this C, that is the column count, and then increment row index after column index can't be incremented, because there is some moment when we can't increment the column index, right? And that moment would be here, then 3 is being achieved, right? So at that moment, after that we can't increment more diagonals at that point, and that's why after this we will be just incrementing the rows. So that's why here we will be incrementing the row indices. So as per these only we will be able to fill up all the diagonals. Basically from whichever we would be starting ahead, we will be going forward in that direction for that particular diagonal. And then what we would be doing is, we will be pushing all the elements corresponding to a particular diagonal to temporary vector, and then after that we will be sorting that temporary vector, and now we will assign those elements of the temporary vector to the original vector. So this is all what we would be doing here, and this is the thing which we are required to implement in our code. So now comes the part for our coding. So let me show you the code walkthrough for this particular question. 1 minute. So here comes the coding part for this particular question. So here you can see that row, then column, and then row index and column index, and then the number of columns we are assigning here. Now here comes the main coding part of this question. So how we are required to do this is, we will be starting from I equals to 1 and going till the number of diagonals. Basically why we are starting from 1 is just because of the fact that each element is starting from 1 and going till the number of diagonals only. And now comes the part that here at every time when we will be starting with a new index, then we will be reassigning our diagonals. Reassigning a diagonal, that simply refers that all the elements inside that will become 0 again, because earlier we had filled the diagonal with some elements, so that's why. Now comes the part, this is the thing which I was explaining you, that until we are able to go through the column count, we will be incrementing our column index at that particular moment of point. That will be C, that is total number of column counts for that particular matrix, minus I. That is, I, if it is 0, then surely total columns would be the total number of column counts only. Means if you start from this particular, right, here I equals to 0. So here column index will be simply as per the total number of columns which are there, right? So that's why we are taking that column index minus that I. Else we will be just incrementing our row index, because if we are not able to if we are not able to go ahead with our columns, then we will be going ahead with our rows, because column could only be incremented only till this particular, right? So that's why. And even here we are starting with 1, right? Not with a 0. So here we will be directly starting from this particular only, and that's why here you can clearly see that that is 4, right? And then 4 minus 1, that is 3. So basically 3 would be the size of that particular. So now let us start that here we are having our I, which is starting from the row index, and at the starting our row index is basically 0, and our column index is basically equals to column index which was there, and that we were having this one, and it was equal to 3. And then here we can take that I less than R, that is the total number of rows which are there, and total number of columns which are there, and then we are incrementing, and accordingly we are basically pushing towards diagonal. So diagonal, that temporary vector which we were taking, that we are doing here, and then we are basically sorting that. And then again we are starting from a row index and column index, and then here k we have taken, so that we could basically here the k is acting as the index to this particular diagonal vector. So that's why we are taking here, and it will be starting from 0, and it will be going until both of these conditions are being satisfied. So that's why we haven't put any condition for this case, and then according to that only we will be assigning to our matrix. Basically at those positions it will be assigned, and then at the end we will be easily able to return whatsoever our answer is. So according to that, because we are first taking according to the columns only, so that's why when we are sorting here, so most of the content is according to the column, means as per the size of the column. So that's why our time complexity is basically C log C, and here the diagonal is basically equals to row plus column minus 1. That is the thing. And as we are having this particular diagonal, means this vector, basically it is storing at max R into C elements. So that's why we have taken the space complexity as R into C. So yeah, this was all for this particular question. So if you have any doubt, you could comment that down, and if you like it, then you can like and subscribe to my channel, and even share among your network. So this was all for today. Thank you.